Hey, what's going on, guys? It's Shaheer from 5 Academy. Welcome back to another video. So today what we're going to be doing is I'm going to be taking the last 10 difficult problems of this ACT Math replica practice exam that we have from the 5 Academy website. I'm going to walk you through the problems, give you an idea of what typically shows up at the end of the ACT Math exam so that you're as prepared as possible for the hardest questions that are on this test. A lot of the skills on the ACT Math repeat from exam to exam, especially in the last 10 problems. So it's important that you take enough practice exams and also just get an idea of what those problems look like through videos like this so that you're, again, like I said, prepared for what's actually going to come your way on test day. So I'm going to skip ahead to the end of the test. I have, as you can see, already taken the beginning portion, but I wanted to record this last portion for you guys, kind of show how I do this, but do the breakdown to kind of show you the skills behind each of these problems. A couple things I'll mention before I start. If you'd like to actually go ahead and take this exam before you watch this video, you can do that on our website. This exam is linked. There's a PDF there. You can go ahead and download it. All you have to do is click the link in the description to our website, make a free account. It takes like a minute, maybe 30 seconds, and you'll be led to a dashboard where you can access the test, as well as more math practice exam PDFs that we have generated. And yeah, and the other thing I'll mention, I would recommend that you use those before you watch the video, just to get an idea of where you stand. And if you run into issues, then you can use this video as a way to review those problems. So without further ado, let's get started. I'm going to take these, like I said, breaking down the skills as well. So this will be a little slower than race pace, but it'll, at the end of the day, hopefully be helpful for you guys. Okay. To make an 800-piece puzzle more challenging, a puzzle company includes 10 extra pieces in the box along with the 800 pieces, and those 10 extra pieces do not fit anywhere in the puzzle. If you buy such a puzzle box, break the seal, and immediately select 2 pieces at random, what is the probability that at least one of them will be one of the extra pieces? Okay, so this is a probability question. So immediately my mind jumps to, what is the key formula or key kind of base information that I need to know for probability? It is that probability of any event, let's call it event X, is equal to the number of desired outcomes divided by the number of total outcomes. So what does that mean? For example, let's say that I have a bag with 4 purple blocks and 2 red ones, and I ask you, what's the probability of randomly picking a red one? You would say, well, what's the number of desired outcomes? There's 2 of them in there, so it's 2. The number of total outcomes, or things in the bag, is 6. So 2 out of 6 is really what I want when I think about what's the entirety of what's in the bag versus what I want, right? So here is want versus everything. Okay? So for this problem, your number of desired is the 10 extra pieces, right? We're trying to get any one of those 10 extra pieces. So when I make that first choice, or when I make any of those choices, there's 10 pieces that I am really aiming for. I don't know which one is which, but there's 10 that I really want. So I want any one of those 10, and when I make a choice. Okay? Now, what's the total? Well, it says it's a 800-piece puzzle, right? So is the total just 800? Not quite, because it's 800 plus the 10 extra pieces. So your total is 800 plus 10. That's 810. Now, if you evaluate this fraction, just do 10 divided by 810, you will end up getting, and I'll just do it on my calculator. I would recommend you do this yourself as well, just to verify. You end up getting 0.0123. Okay? So it's a kind of a tricky problem. You want to make sure you don't miss this right here, and the best way to do that is to just keep in mind the formula, and that'll help you kind of just make sure you don't overlook that key step of adding the 10 into the denominator. Otherwise, you'll end up with answer option B, which is incorrect. Moving on, what is the 245th digit after the decimal point in the repeating decimal here? So obviously, in order to write this out, you'd have to write out 0.149714971497, 245 digits down, which is just not practical. The best way to do this is actually just treat it as a pattern problem. You see that the pattern is that every 4 values, you have a 7. So every first value, if I was to write out the values, right, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? I notice that every 4 values is a 7. I notice that value 1, 5, 9, 13 would be ones, etc., right? Now, the reason I'm singling out the 4s is because I can make a ratio saying, let's say I want to get to value 400. I know that's going to be a 7 because it's a multiple of 4. Notice 4, 8, 12, all those are multiples of 4. So any digit that is that has a count of being a multiple of 4, like for example, what's the 28th digit? What's the 400th digit? What's the 4,000th digit? I can tell you that it's going to be 4 because every fourth value is 7. Okay, I can tell you it's 7 because every fourth value is 7. All right, so how do I apply this to this? Well, check. Is 245 divided by 4 divisible by 4? No, it's not. But let's check, for example, let's see, 244 maybe? 244 divisible by 4 gives you 61. That means that this number is a multiple of 4, which means the 244th value is 7. So if I just go one value over, let's say this is 244 right here, or sorry, 244, this is 244. 245 would just be the next one here, which would be 1. Okay? So you use the pattern and you leverage the fact that a multiple of 4, as far as the nth digit from the decimal, is always going to be a 7, and that's how you get your answer here. Okay, so that type of problem is quite repetitive. I've seen it a lot, so just beware of that type of thing, and mapping out the ratio usually helps a lot. Mapping out the pattern, sorry. Company A wants to hire 18 new employees. The diagram below illustrates a part of the process of the job application. 18 employees will be selected from an applicant pool of 90 people. Hiring records indicate that only 30% of applicants who apply are invited to be interviewed. Of those applicants who interview, only 2/3 are hired. If the same trend continues, how many people need to apply to work at Company A to have 90 new employees at Company A? Okay, so 90 new employees at Company A would be right here, right? We want 90 new hired employees. Now, let's kind of just follow this back up the chain. We need to find what the numbers would be because it's asking how many people need to apply. So we need to find this number, which means we need to find this number. Okay? So what's the relationship between hired and interviewed? It says, of those who interview, only 2/3 are hired. So whatever this number is, take 2/3 of it, and that's what the number of hired is. Okay, so I can easily go down the chain that way. So some number times 2/3 is equal to 90. Let's just call it x. X times 2/3 is equal to 90. I can just multiply both sides by the reciprocal. These two cancel out. X is equal to 90 times 3/2, which is equal to 135, okay? That means if I have 135 people that interview, I will get 90 hires, okay? Because only 2/3 of those that interview end up getting hired, okay? Now let's, again, go back up the chain. What's the relationship between applied and interviewed? Applied and interviewed. So only 30% of applicants who apply are invited to be interviewed. So whatever this number is, take 30% and I get interviewed, okay? So we'll call this number y. Y times 30%, which is 0.30, is equal to 135. And you see how this number is crucial now because I need it for this part of the problem. If I got that first step wrong, I'm going to get this step wrong. Okay, so let's just divide both sides by 0.30. Isolate the y. Y equals 135 divided by 0.3. It's 450. That's my answer. Okay, so from here to here, let's go from the top. It's 30%. Here to here is 2/3. And that's how I get from 450 to 90. Okay? Another way to do it is to just calculate. You can go directly from applied to hired by just calculating, okay, 0.30 times 2/3 is just equal to 0.20, which is just 20%. You'll notice that 90 is just 20% of 450. Okay? You can do that as well. It's kind of skipping a step. It's a little risky, but if you really want, you can do that. Moving on. If I equals square root of -1, then what is this? This looks like a mess. How do we solve this? And how do we get anywhere close to an answer option that looks like this? Let's just take it one piece at a time. Treat this as 6 individual problems. We'll start with the simple one. I is equal to square root of -1. Okay? Simple as that. We'll just leave it at that. I squared, we know, is equal to square root of -1 squared, which is equal to -1. Okay. I to the third. How do we calculate this? It's kind of hard to do, right? You don't really know what I to the third is, but what I do know is it's I squared times I. Okay, now we're kind of, you might think, how is this going to help us? What I realize is that I actually have this right here and this guy right here. Let's just simplify it. So I squared is equal to -1, right? So let's just substitute -1 and I. I end up getting -I. So this entire denominator ends up being I plus I squared, which is -1, plus -I, which is equal to, well, I minus 1 minus I, which is equal to -1, because the i's cancel out. So my denominator is just all of that, this atrocity, is -1. Okay, so now we see this, where this might be going. This numerator might also simplify to something very, very simple. So let's see where that takes us. I to the fourth. What is I to the fourth? Well, we can model it as I squared times I squared, which I know both of these are just -1, right? -1 times -1, easy. That's just going to be 1. So 1. I already know I to the third. Just borrow that from here. It's -I. I to the fifth. Let's just call that I to the fourth times I, which is just going to be 1 times I. That's equal to I. Okay, so -I plus 1 plus I. That gives you 1. Again, this cancels out with that. So 1 on the top, -1 on the bottom, that gives you 1 over -1, which is equal to -1. So what we did is we took this horrible looking problem that's just looks very messy and unsolvable, and we reduced it to this. And we took this and leveraged it for each of these individual steps, and we were able to get a solution. So that's how you do that one. Again, complex numbers, they show up a lot. This I equals square root of -1. So being able to use that and manipulate it, I feel like this is a really good example of that. And I encourage everyone to understand this example. Watch it again if you need, maybe at half speed if you want. That'll help you understand how to really apply the rules here, because it is crucial. It's asked about on every test. Moving on. Given that f of x is this and g of x is this, what are all the values of x for which that is equal to 0? So how do we find f of g of x? What this is saying is you take f of x, you get rid of, so f of x is equal to x squared minus 9, right? And what we do is we, instead of x, now we substitute in g of x. F of g of x, which is, okay, so what do I do now? It's just g of x. What you do is you substitute all your x's with g of x. Okay, so now g of x, let me write it this way, is going to be squared minus 9. And what is g of x? It's actually this right here. So I can just plug in x plus 5 squared minus 9. Now I can solve this. I can solve this because, and it's asking us, right, to make this equal to 0. We want to find where f of g of x is equal to 0. Now I can solve this by kind of expanding this, doing the quadratic formula. I can do factoring. I can also just move the 9 to the other side. So 9 equals x plus 5 squared. Take the square root of both sides. I get plus or minus 3 is equal to x plus 5. And that'll turn into, I'll basically have two solutions. This is kind of like completing the square. So it's either plus 3 is equal to x plus 5. Subtract 5 on both sides. -2 is equal to x. Or I get -3 is equal to x plus 5. Subtract 5 on both sides. X is equal to -8. -2, -8. All right, that's the answer. You can test it if you want by plugging these back into f of g of x. But that's what I'm going to leave it at for this one. Given that a is a positive number, b is a negative number, and absolute value of a is greater than absolute value of b, which of the following expressions always has the greatest value? Okay, this can be very confusing just looking at it. What I would say is immediately assign numbers for a and b that meet these conditions, and then just test them in each of the answer options, okay? So a is a positive number, b is a negative number, and absolute value a is greater than absolute value b. So let's just say a is equal to 2, b is equal to -1. and absolute value of a is greater than absolute value of negative 1. 2 is greater than 1, right? Great. So I'm actually going to do, let's make this 3 and negative 2. Sometimes using, for examples like this, using 0 or 1 or negative 1 can sometimes be a little tricky. So it's better to use numbers that are not 0 or 1, okay? Now, let's just plug them in, see what we get. We want to find the greatest value. So 3 minus 2 over, let's do this, I'm going to make it clear. 3 plus negative 2 is equal, over 3 is equal to 1 over 3. And that's all absolute value, right? Is equal to 3 minus 2 over 3 plus negative 2. That's equal to 5 over 1. It's equal to 5. This is equal to 3 minus 2 over 3 times negative 2. This is equal to 5 over negative 6, which is equal to 5 over 6. So far, this one's winning, right? Equals a plus b. So 3 plus negative 2 over a minus b. So 3 minus 2 is equal to 1 over 5. This is negative absolute value. So we end up getting 1 over 5. And this one is equal to a plus b, 3 plus negative 2 divided by negative 2 minus 3. That's equal to 1 over negative 5. Absolute value, all of it. Negative 1 over, it's just 1 over 5. So you don't actually have to go through and solve all these. What you'll notice is the only one that ends up being the biggest is the ones that has a negative in the numerator and a positive in the denominator. That's just the way the numbers work out. It's because in the numerator you end up subtracting a negative here, and that ends up with a very large numerator. And then when you add in the denominator, it ends up with a very small denominator. So big numerator, small denominator means big number. Okay, answer is B. So using this strategy of when you're given these number problems where it's just letters everywhere, plugging in numbers and evaluating everything paints a really easy picture for you to identify what's actually going on. Now just be careful, like I said, with using 0 and 1. It'll skew your results, and it might even give you 2 answer options that seem correct, which can be very confusing during the test. Let A, B, C, and D be real numbers. Given that AB equals this and AD equals that, ABC equals D, which of the following must be true? Okay, so there's a lot going on here. So what can we just take away from this? AB equals 100. Doesn't really tell us much. AD is equal to 0. Okay, this is telling us something. If I tell you I multiply 2 numbers together and it equals 0, that means that at least one of them is equal to 0. I can't get 0 any way through multiplication other than by multiplying something by 0 or multiplying 0 by something, right? I can't get 3 times 2 equals 0. There's no 2 numbers that'll give me 0 when I multiply them together unless it's 0 times 3 equals 0 or 3 times 0 equals 0, which is really the same thing. What does this mean? It means that out of A and D, that's the wrong pencil, either A or D, let's call it A and or D, are equal to 0, okay? Either or, we don't know which one. And then we see here it says, and also here, this is another clue. Now, we're not sure which of A or D is equal to 0. And here, I'm told that A times B is equal to 100. If A times a number gives me a number that is not 0, that means that A, I guess, yeah, A can't be 0, right? Because if A was 0, then this would be 0 too. So what this means, D is 0. Okay? D is 0. We just determined that using just these 2 things right here. Okay? Now let's look at the last one. A, B, C is equal to D, which is really saying is equal to 0. A, B, C is equal to 0. Now, I know that A, B is equal to 100. So this is really saying 100 times C is equal to 0. If I divide both sides by 100, I get C equals 0. Right? Because again, the only way to multiply 100 by something and get 0 as an answer is for that something, C, to literally be 0 itself. So D equals 0, C equals 0. Okay? The rest of them doesn't matter because we know for a fact this is true. Only one of these can be true, right? There's only one correct answer. So that's the answer here. All right? The figure below shows a laser beam pointing at the moon. At a certain moment, the laser beam forms an angle of elevation of 80 degrees from point X on the ground. At the same moment, the angle of elevation of the moon to point Y is 35 degrees. The distance from point X to the point Y is 4,000 feet. What is length in feet of the laser beam to the nearest foot? Here to here is what we're looking for. We're told the angle of elevation is 80 degrees. From the moon to the point Y is 35 degrees. And point X to Y is 4,000 feet. Okay, and we want this distance right here. So how am I going to get that? First of all, when you're given two angles, you can immediately solve the last one because it's a triangle. So just do X plus 80 plus 35 is equal to 180. Subtract 80 and 35, we get X equals 180 minus 35 minus 80, 65, okay? So I know this angle here is 65. I've immediately made this problem a lot easier. Now what I can do is I can use law of sines. Law of sines is very useful when you have three sides and three angles and one side, or three sides and one angle, okay? So let's just say this is angle Z. Let's just say sine of Z over side length Z, which is opposite it. So this is going to be side length lowercase z. This is going to be side length lowercase y. This is going to be side length lowercase x, because they're all opposite each other, okay? Understand the opposite bit. It's just which side does the angle kind of open up to. So sine z over z is going to be equal to sine of y over lowercase y. So sine of angle z divided by the side length z is equal to the sine of angle y divided by the side length of y. Okay? We know everything in this equation other than the side length here. So I can just solve for that. So let's just plug everything in. Sine of 65, which is angle z, divided by the opposite side length is equal to sine of this angle 35 over this side length. We'll call it, just call it y. All right. Now I can just do cross multiply and divide. Y sine 65 equal to 4,000 sine 35 divided by sine 65. Y is equal to, so let's do 65 sine, multiply that by, hold on, we have to do 35 sine divided by 65 sine times 4,000, 2531. Yep, it doesn't seem like the numbers really make sense given that the moon is quite far away. But according to this problem, the moon is 2531 feet away. So whoever wrote the problem, good job. I don't know what planet you're on, but that's the correct answer here. So hopefully that method made sense. The idea here is just using law of sines to leverage the information you have and identify what you don't have and solve using the equation. If you want the whole equation, it is sine of angle A over side length A is equal to sine of angle B over side length B is equal to sine of side length angle C over side length lowercase c, okay? So it's an interesting relationship between all the angles that you can use given what knowns you have. In this case, we had two angles and a side. We were able to find the last side. Okay, that's really how it works. If a copywriter charges $250 for an original slogan and $30 for each additional use of that slogan, which of the following expressions represents the cost Y of slogans? This seems like a normal Y equals MX plus B problem, right? It's like, okay, I know that my original value is 250, so if I was just plugging into, I'm not going to use X and Y for this scenario because they use Y already here. So let's just call it A equals MY plus B, okay? Same thing as Y equals MX plus B. I just kind of rearranged the A and that, okay? So I think, okay, so the original charge is 250, so that has to be B. And the $30 for each one is going to be M. So it's going to be A equals 30 Y plus 250, right? Done. Or sorry. But that's actually wrong. Because this 250 value here is the value for one item, for an original slogan. It's not the value for 0 slogans. And the Y equals MX plus B form, this B value is supposed to be the value when you have 0 input, i.e., what would be the cost if you had 0 slogans? Now, obviously, that would be 0. But that's kind of the connection I want you to draw. The y-intercept does not actually match up with this right here. Okay, so the best way to solve this is actually to use a table. So let's just do y and cost. So let's just plot, if I have 0, right? If I have 0 slogans, then my cost is going to be 0. If I have 1 slogan, it's going to be 250. If I have 2, it's going to be 250 plus 30. If I have 3, it's going to be 250 plus 60, right? And it just goes on. You see, just add 30 every time. If you were to put this into an equation, let's just take these 2 points, for example. So I have 1 comma 250. I have 2 comma 280. Plug it into y equals mx plus b. So I have 250 equals m plus b, and I have 280 is equal to 2m plus b. I'll just do some subtraction here. Negative 30 is equal to negative m. So my m is obviously equal to 30. Now let's plug that back in here, identify what b is. So 250 is equal to 30 plus b. That means that minus 30, my b value, if I was to put this into an equation, would actually be 220, not 250. It would be 220. So my answer is E. Okay, hopefully that made sense. It's because, again, the b value for a y equals mx plus b form equation has to be when essentially the y value when your x input is 0. But since this value is not representing the cost for 0 slogans, rather the cost for 1 slogan, you can't use that and just say it's your b, or essentially your y-intercept. Okay, hopefully that makes sense. If this said, yeah, I'm going to kind of leave it at that. Hopefully that works and that makes sense. If you have questions, what I will say, if you have questions about any of these problems, feel free to leave a comment down below, or even better yet, respond to our chat on our website. And just let us know, hey, I'm interested in scheduling a free tutoring session, 15 minutes. I want to go over some of these questions that you went over in these videos. In a window display at a clothing store, there are 2 mannequins, each of which can display one combination of a shirt and pants. To fill these 2 mannequins, John has exactly 4 shirts and 2 pairs of pants to select from, each different from the others. Selecting from these, John can make how many possible display arrangements on the 2 mannequins? The position of unselected shirts and pants do not matter. Okay, so what's a combination? How do you do this? You might just think, okay, 4 times 2, easy, it's 8, but that's obviously not an answer option, so what's going on here? 4 times 2 would be the answer if it was 1 mannequin, but the thing is it's 2, so you have to find how many ways can you distribute all these things across the 2 and share, which makes this a lot more complicated. But there are some formulas that can make it less complicated. Let me show you those. NCR, so I'm going to write them out, and then I'm going to just explain them to you. It's N in the numerator. And then we have NPR is equal to N permutation over N minus R permutation. Okay. So the best way for me to explain what's actually happening here is N is your number of items. R is your number of spots. Okay. So for example, let's just give a very simple example. Let's say I have A, B, and C. There's 3 letters, and I ask you how many different ways can I combine them? How many combinations of A, B, and C if I can only combine 2 letters at a time? Okay, so I would say, you might think, okay, A to B, B to C, C to A. So I have A, B, B, C, C, A. Great. Now what if someone else was to say, okay, what about B, A, C, B, and A, C? Are these counted as the same combination? Because these are the same 2 letters in each of these pairs, but I don't know if I should count it or not count it. So these 3 are actually, you would just count this as each of these pairs, these 3, each of these pairs is a combination. Okay, but each of the individual things and the individual items in across all the pairs, those are all the permutations. So I have 3 combinations. I have 6 permutations. That's the way to interpret this. Okay. Now, let's apply that to the formulas just so we see everything tie together. So n is the number of items, r is the number of spots. So here I have 3 items that I want to pair together, right, with each other. And I have 2 spots because I'm trying to pair them together. So let's do n CR and call it 3 combination 2, which is going to give me 3 factorial over 2 factorial times 3 minus 2 factorial. That gives me, now if you don't know what a factorial is, so if I give you 5 factorial, it's just equal to 5 times 4 times 3 times 2 times 1. If I give you 10 factorial, it's equal to 10 times 9 times yada 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 times 2 times 1. Okay, you just basically multiply all the numbers less than it until 1. So NCR for this gives me 3 times 2 times 1 over 2 times 1 times 1 is equal to, this cancels, this all cancels, it's just 3. And that aligns with what I told you, right? It's 3 combinations. Now let's do the permutations formula. Let's plug this in. So I'm going to do 3 permutation 2 is equal to 3 factorial over 3 minus 2 factorial. That's equal to just 3 times 2 times 1 over 1. It's equal to 6. So it lines up, right? It all lines up. Now let's apply all of that to this problem. So what are we doing? We have 4 shirts and 2 pants to select from. So yeah, let's just look at shirts. Forget the pants for a second. So there's 4 shirts, 2 spots. Okay. So I'm going to do 4 permutation 2. That's equal to 4 factorial over 4 minus 2 factorial. It's equal to 4 times 3 times 2 over 2 times 1. This cancels. I end up getting 12. Now, it's 12 if I just focus on the shirts. Now there's 2 pairs of pants. The best way to consider this is actually just think of it as, okay, I have all my shirt combinations or permutations. Now imagine I have one set of those with 1 pair of pants and then another set with just the pants flipped. So really it's 12 plus 12. And that puts you at 24. Okay, so it's kind of a unique way to solve the problem. It's a little more difficult. I don't know if there is a way to solve this if this was more than 2. And I don't think the ACT is going to test you on that. But really what you need to focus on here is just, it's 4 shirts. You use the permutations formula. And if you try the combinations when it doesn't even work, so you don't even need to know the difference here between combination and permutation, but you use the formula, you do it, and you end up with this answer right here. Voila, okay? Because there's 2 pairs of pants. All you got to do is just flip them, and you take the shirt combinations or permutations and just multiply by 2 because you have 2 pairs of pants and you just flipped them, all right? So that's all that I have here. Hopefully this was helpful. If you have any questions, like I said, drop a comment down below. Give us a chat on our website. You can even schedule free tutoring with us. We actually do free 15-minute tutoring sessions with students. Any student who asks for a tutoring session, we'll give you a tutoring session. You can schedule it when you want. We have free tutoring resources that are available to help you guys out. We want to make tutoring accessible. We want to make ACT prep accessible for everyone. And that's exactly what we try to do here at 5 Academy. So if you have questions, let us know. Schedule a session. There's links down below. And I look forward to talking to you guys in the next video. See ya.